All right, quadratic functions. So let's recall that the standard form for a quadratic function is f of x equals ax squared plus bx plus c. Now remember, f of x is just the funky way of just saying y. So this is still an equation where a cannot equal 0. Okay, cannot equal 0 or this does not work. Now, this is a polynomial. Okay, this one has what they call a degree of 2, which is just meaning 2 roots. Roots, remember, are just a funky way of saying x-intercepts, of where they intersect at the x-axis. Okay, there's always going to be 2 of them. Okay, and the exponents are squared. The graph of a quadratic function is called a parabola. It's a really weird word, parabola. Okay, so it wants us to know whether or not these equations are quadratic. There's a couple things that I can do when I look at it. One, I can look at this one and be like, oh, that exponent's a 3. That is not quadratic because its exponent is 3. Okay, now this one does have a square, so yes. Now this one has an equal sign and then a constant on it. Now, going back to our equation, everything has to be together. So can I rewrite this so that that 4 is on the left side? Well, yeah, I can subtract 4 and then it's equal to 0. So yes, this is also quadratic. Same thing for this one. I can take this expression, do the inverse operations, and move it to the left. So that would be a negative x squared plus 3 equals 0. Again, exponent is squared. Yes, it does work. Okay. Now, sometimes when we're given an equation, we need to be able to realize what that a, b, and c is. So a is your coefficient to your x squared. So that would be 3. B is the coefficient to our x. That's a negative 4. C is our constant, which in this instant is 7. Okay? So now we're given an equation and we need to create a table of values. Now when I do a table of values, I always start with nice numbers, like negative 2, negative 1, 0, 1, and 2. So if I were to put negative 2 in here, so negative 2 squared is 4, minus 4 is 0. Negative 1 squared minus 4 would be negative 3. 0 squared minus 4 would be negative 4. 1 squared minus 4 would be negative 3. 2 squared minus 4 would be 0. So if I plot those, negative 2, 0, 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. That has created that parabola look, that curved look. Okay? All right, let's go to the next part. So, when we are given quadratic functions, we are asked to solve them. When we are solving them, we are finding the values that x can be to make the equation equal 0. Those solutions to a quadratic equation can be called one of 4 things. You can call them solutions. You can call them x-intercepts. You can call them zeros, or you can call them roots. They all mean the same thing. They're interchangeable words. So, the solutions, the x-intercepts, the zeros, the roots, whichever word you want to call them, occur where the graph intersects the x-axis. Okay? And you can graph them. So graphing can be used to determine the solution to an equation. Okay. Now, when you're looking at equations, there are certain things that you can see. So if I were to look at this equation, I see that this graph is hitting that x-axis technically one time, right here. So we would say this has one solution, which we would identify as 3. This graph doesn't come near my x-intercepts, so it has 0 solutions. On this one, it crosses twice. So it has 2 solutions where we would say x equals -2 and x equals 1. All right, now this is where Desmos is amazing. We can use our Desmos to help us graph and find our solutions. So I'm going to pull out my graphing calculator and clear it all out. And we're going to put in our equation. So we're going to say x squared minus 5x plus 6. I don't need to put 0. I'm okay with that. But I do need to kind of zoom in some because I really can't see that x-intercept. Kind of fuzzy. So as I zoom in, oh, look, I see 2. So there's an x-intercept there at 2, 0. And then we have another one right there at 3, 0. Notice it gives me even the points. Look at that. So in my notes, I would say x equals 2 and x equals 3. Those are my x-intercepts. So I'm going to do the same thing with my next set. So I'm going to go in and I'm going to say x squared plus 8x plus 12. Oh no, my graph's not there. Oh, you're going to have to change your zoom, and you can literally click and it keeps them there. So we have x equals -2 and x equals -6. All right, let's look at question 2. So this one is 2x squared plus 4x plus 7. Oh, this one's not touching. So this we would say has no roots. It does not cross that x-intercept. All right, let's do number 3. This one has 2x squared plus 10x plus 7 or plus 0. So let's get rid of that. All right. So let's look. All right. So there's 1 and there's 2. So I would say x equals -5 and x equals 0. Yes, 0 is a root. It's okay. All right. Let's go to number 4. All right. So notice on this one, I need to rewrite it. So it's got to be x squared plus 3x minus 18. So let's go in our Desmos, x squared plus 3x minus 18. So we have our x equals -6 and x equals 3. All right, let's do question 5. So 3x squared minus 2x plus 4. Oh, we have no roots. All right, and then we have our last one, or number 6, sorry. X squared minus 49. So x squared minus 49. All right, so let's look at our picture. There we go. So we have x equals -7 and x equals 7. Those are our roots. All right, let's keep going. Question 7. Oh, look at this one. This one's weird. Watch this. X plus 2 times x minus 4. Oh, got a whole bunch of extra. All right. Now, I know this one's got some extra parentheses. That's okay. All right, so here's our points. Oh, I got an extra x in there. Hold on. That's why. There we go. Now we got our points. So I have x equals -2 and x equals 4. Well, that's interesting. You notice that? 2, 4? Huh. Let's see if it works for the next one. So we have x plus 3 squared. So we're going to say, let's delete all this. X plus 3 squared. So we have x equals -3. All right, now we have our last one. What do we notice about this last one? It's not quadratic. So this one's probably going to be, not probably, it is a linear equation. No, it wasn't typing. Y equals 2x plus 4. So x-intercept is x equals -2. And that's all it is to quadratic functions. Again, using that Desmos to help us.